Okay, so in this video we're going to be talking just in general about antiderivatives. What is an antiderivative and how do you do some pretty basic stuff with them? So what is an antiderivative? It's probably not too hard to guess that it's just the opposite of a derivative. So, but more specifically, you already know how to take the derivative of a lot of things. If I give you the derivative, ask you the derivative of x to the fourth, you know to do the power rule. You get 4x to the third. If I ask you the derivative of sine x, you know that's cosine x. If I ask for the derivative of tangent x, could tell me that's secant squared. And for a bunch of other ones you can tell me. Some of them will be product rule, quotient rule, whatever. But what an antiderivative is it goes the other way. So here's the symbol we use when we write this big curly S, and I put a function inside. At the end of it, this is just notation, don't let it freak you out. It's actually going to make sense in a couple weeks why this notation is the way it is. But if you see just a big curly S with a dx on the end and a function inside, all that means is what function has a derivative of 4x cubed? And the answer is, well, x to the fourth. That's all it is. So when you see this big curly S, you know it's asking you a question. It's not asking you to take a derivative. It says, what is this the derivative of? What function, when I take the derivative, gets me 4x cubed? So if I ask you, what's the antiderivative of secant squared x dx, don't worry about the dx, it's just there for now. You would ask first, what function has a derivative of secant squared? And then I'll say tangent. If I ask you for the antiderivative, that's curly s, of sine x, of cosine x, you would say, what function do I take the derivative of and I end up with cosine? The answer is sine. Sorry, I left out a dx there. So that's all it is. It's not too bad. So now we want to be able to build up rules just like we did for derivatives for these kinds of things. So now what about the power rule? So for derivatives, what was the power rule? The derivative, when you give me x to the n, is nx to the n minus 1. There were two steps to this. First, I had to bring the power down and multiply by that power. And then second, I had to subtract 1. So for antiderivatives, this is you just have to do the opposite. So, but if it's a little weird, you have to do these steps in reverse, but you also have to do the opposite of them. So you do them backwards and you do the opposite. So for antiderivatives, what are you going to do? You're going to do this one, but you're going to do the opposite. So you're not going to subtract 1, you're going to add 1 to the power. And then second, you're going to do this one backwards. Bring the power down and multiply. What's the opposite of multiplying? You're going to divide by that power. So if I ask you, what is the antiderivative of x to the 8th? You would add 1 to the power to make it x to the 9th, and then divide by that power, x to the 9th over 9. So there's your power rule for integrals. If I want to take the antiderivative, if I want to take the antiderivative of x to the n, I know I have to add 1 to the power and then divide by that power. And that's it. The last thing I'll say is that you'll usually see something on the ends of all of these antiderivatives. You will always see at the end of every answer a plus c. Now, what does that mean? Well, let's go back to our example, x to the 8th. Remember, this is a question baked in here. What function has a derivative of x to the 8th? Well, it's x to the 9 over 9. If I take the derivative of this, you can check it. You bring the power down, and the 9 will cancel, and then you minus 1. But apart from that, it's x to the 9 over 9, but there's another function that I can take the derivative of, and I get x to the 8th. What about plus 2? If I take the derivative of this, the 2 goes to 0. If I take the derivative of this minus 10, this is also a function whose derivative is x to the 8th. I can add on any number on here. I can do plus pi, minus 2 plus e squared minus a 7th. And this function will also have a derivative of x to the 8th. Those functions are not any more correct than just x to the 9th over 9. So when you do an antiderivative, we add a plus c on the end of it to indicate that you can put a constant on the end and not change the answer. Any function that looks like this will have a derivative of x to the 8th. Now, this was just an intro, so there's not too much to it. We'll get into more details later.